First, let us see the difference between automated machines and robots. Basically, this both are same, but it has one important difference, that is ability to think. Let's have an example of CNC machine. It is reprogrammable. If there is a sudden intervention while machining, CNC machine cannot react. It will do its duty very well and stops after demolishing the other parts. But in robot, it's not like that. It will sense, think and react with the external environment. So I hope you can able to understand the difference between automated machine and robots. And next is we are going to see the 3 laws of robotics. I hope you have seen the film Endiran. In that film they told about this 3 laws. A robot must not injure human beings. That is, if we have a robot which is programmed to do one specific operation, then it should not injure the human. The second law is it should obey the commands given by the humans. According to the second law, if a programmer programs a robot to injure a human, it is not possible. Okay, then the robot must protect its own existence as long as such protection does not conflict with the first law and the second law. These are the 3 laws of robotics. Now we are going to see the parts of a robot. It is also similar to the human body. First thing we need to build a robot is base. It is called a robot base. It is fixed to the floor or a mobile base. For example, a robot is on wheels, then it is called as mobile base. In industrial robot, typically you don't have a body, it is called arm. It should be rigid enough to do the operation. Say for example, if you are constructing a pick and place robot, the next is robot wrist and grippers. We are going to see the robot accessories. First is actuators. It helps to make the relative motion between the links such as servo motors, stepper motors, pneumatic cylinders and hydraulic cylinders. Next is we are going to see sensors. Helps to collect the data to react with the external environment. Vision system, touch and tactile sensor are some examples for sensors. Based on the path followed by the arm, it is divided into 2 systems. That is point-to-point system and a continuous path system. Let us see point-to-point system robots. For example, we have a pick and place robot. If it follows point-to-point system, then path is not controlled, so the trajectory is arbitrary. It is not a constant, it is arbitrary. The time required to move is called as t in terms of seconds. Let's have an example. A pick and place robot have to move 120 degree in x-axis in t seconds. If that robot follows point-to-point system, then any changes in degree, then the completion of relative motion is in same time t seconds. I mean, if we are going to change the 120 degree to 10 degree means, then it makes the same time t. This is called point-to-point system. In continuous path system, all the axes move simultaneously, each at a different velocity. In this case, the time t is different for different axes. Velocity is coordinated under a computer control here. Some of the examples are spray painting, arc welding, etc. In these examples, velocity is very important. It is directly proportional to the quality of work too. Next is open loop control system. In this case, control is given to the individual axis and there is no feedback obtained about the position, velocity, etc. In this figure, you can able to see the control unit, driver and a motor. In general, all the relative motions are obtained by motors. The data for the position of motor was not obtained. Example is pick and place robot without feedback. Next is closed loop control system. In this case, we can obtain a feedback. I mean the position of a motor. It is done by encoders. The signal or feedback is called as corrective signal and it is given to the microcontroller. This controller adjusts the signal to the motor and it meets our requirement. This is called closed loop control system. Servo motor, applications of servo motor, stepper motor, applications of stepper motor we are going to see in our next episode. Thank you for watching. Thank you very much.